This is linear algebra. We're gonna do matrix equation. We're gonna rewrite the linear combination as product of matrix and vector. Guys, here it is. Guys, look at this one. This is a matrix, okay? A matrix. This is one row, one times n, 1, 2, all the n columns. How about x vector? Vector is gonna be this one is how many row? 1, 2, n. That's m row times one column. So we're gonna product of matrix and vectors. You guys make sure this is n is exactly same n. How can do product of matrix and vector? x1, a1 column. So x1, a1, x2, a2, xn, an. That's you write the product of matrix or vector, guys. I'm gonna give the example of the matrix and vector. Here we go. We're gonna find matrix times vector. You're gonna give a metric and this form. How many? This one is this. Each one is gonna be a1 vector. Here is a2 vector. Here is a3 vector, right? So you have a 3-column vector. Here is the other way you write A is metric gonna be a vector, a2 vector, a3 vector. So that's the metric A. How about X? It's gonna be 1, 2, 3. 3 row, 1 column. So here is gonna be, how can they find A metric times X gonna be 4 times A1, 3 times A2, 7 times A3. So the other way, you're gonna rewrite this metric gonna be, guys. You're gonna see this one. You're gonna put 4, 1, 0, 3, 2, negative 5, 7, negative 1, and 3. That's how to rewrite linear combination as a product, metric, and vectors. Guys, make sense? Okay, let's practice couple more, guys. Look at this one, okay? So next one is write the linear combination of 3v1. That's the linear combination, right? This one is x1. Second is x2. Third is x3. So what are you gonna put the A metric? A metric is have 3-column vector. What is vector here? V1, V2, V3 vector. 3-column, right? 3-column vector. What is X metric? X metric is x1. That's the column vector. x1 is 3. x2 is negative 5. x3 is 7. So how can we write this linear combination? 3v1 minus 5v2 plus 7v3, which meaning is matrix A is v1 vector. Here is gonna be A vector times X vector. That's you write this one, guys, okay? Another way this one is you see v1 vector, v2 vector, v3 vector, X gonna be 3, negative 5, 7. So that's another way you write the linear combination as product of metric and vectors. Okay. Let's discuss what you learned so far. We have different form of linear equation, metric, vector equation, and metric equation. So how they related? First, system of equation, I give the example, guys. This one is 2 equations, 3 variable. Can you change this one is augmented metric, right? Let's change augmented metric is. First row is 1, 2, negative 1. That's gonna be 4. Second row gonna be 0, negative 5, 3, and 1. That's augmented matrix. Now, you wanna write this one is gonna be vector equation. Vector equation gonna be x1. You're gonna write x1. What is a1? A1 gonna be right here, guys. A1 gonna be here. That's the A1 vector. Here is A2 vector, column vector. Here is A3 vector. Here is a B vector. So this one is gonna be 1, 0 plus x2, 2, negative 5, x3, negative 1, 3. B vector is 4, 1. How about metric equation? Metric equation is gonna be combine all the column matrix is A. So here gonna be A, matrix A gonna be A1 vector, A2 vector, A3 vector. So this one gonna be, what is A1? 1, 0, 2, negative 5, negative 1, and 3. So that's gonna be A vector. X vector gonna be x1, x2, x3. So B vector gonna be, you already did B vector, right? B vector gonna be 4 and 1. So we're gonna write A vector, A metric, X vector equal B. Guys, make sure all the 4 different forms represent the same thing. We're gonna solve, guys. Look at it. System of equation. You solve the augmented metric, solve the vector equation, solve the metric equations. All through is same meaning, guys. Okay. Let's talk about very important theorem. Previous slide, I'm gonna show different form of system of equation, vector equation, and the metric equation and augment metric. Based on that notation, we're gonna see all 4 statements are true. First one is every time you're gonna give the B, AX plus B metric equation as a solution, which meaning is B is linear combination. So A metric is looks like A1, A2, column metric, AN. That's gonna be B metric, B vector gonna be XA1, XA2, XNAN. Guys, make sense? And then another way, column of A span Rn, which meaning is Rn gonna be span A1, AN. Okay? Another one is A has the pivot position in the each row. Guys, very careful this last statement. A is metric, not the augment metric. Metric, coefficient metric has a pivot position in every row, which meaning is column metric of A span Rn, guys. All 4 statement is the same, okay? Let's give the one example, this one. I give the A metric, I give the B vector. So they say AX equal B is consistent, which meaning is, what do you mean by this one? AX to B metric equation has a solution. Why not? That's we're gonna check it, right, guys? So let's solve this one. So how can solve it? Let's change this metric equation into the augment metric, guys. Okay, what is augment metric about this? Simply like this one is, guys. Look at this: 1, 2, 0, 2, 1, 3, 2, 3, 1. That's the coefficient metric. What is it? Constant metric: B1, B2, B3. So we want to check this system of equation have solution or not. That's we know AX equal B metric equation as a solution, okay? So let's solve this one, guys. Let's solve it. I want to save some time, guys. Make sure, guys, this one is gonna be we have to do a little quickly, guys. Let's do this one. So I'm gonna do 2 rows at the same time. What do you need here? You make it 0, so you need a negative 2. So negative 2 times R1, here it is right there. So negative 2 times R1 is right there. I'm gonna put negative 2, negative 2, negative 4, 0, negative 2B1. Everything make sense? Okay, third one, negative 2, negative 4, 0, negative 2B1. Okay, so now what you did, negative 2R1 plus R2 going to R2. Negative 2R1 plus R3 going to R3. So you have new augmented matrix 1 to 0, B1, 0, negative 3, 3, B2 minus 2B1. How about the third row? 0, negative 1, 1, B3 minus 2B1. Guys, make sense? Okay, go to the next one. So what do you have to do, guys? What do you have to do? This one, this guy is, here is pivot, right? Here is pivot. So this might, sure, this one gonna be 1. But negative 3, you're not gonna divide by 3, a little complicated. I wanna interchange R1, R2, and R3. So many different way you do the row operation. Make a pivot is 1, guys. Okay, this is 1A. 1 to 0, B1, 0, negative 1 and 1, B3 minus 2B1, 0, negative 3 and 3, B2 minus 2B1. Okay, so this guy should be 1. So what do you have to do here? Negative 1 R2. Okay, so that's going to be go to the R2, guys. Okay, so what do you have to do? Negative 1 R2 going to R2. So you times negative right there, guys. So you have this one. 1 to 0, B1, 0, 1, negative 1, 2, B1, minus B3, 0, negative 3, 3, B2, minus 2, B1. Okay, so you have pivot. This guy gonna be 0, right? So what you have to here, you guys do here, 3, R2, right here, 0, 3, negative 3. So 3 times 2B1 minus B3. That's gonna be you doing raw operation, right? So 3 R2 plus R3 going to R3. So you have new one. 1 to 0. 0, 1, negative 1. B1, 2B1 minus B3. Here is a 0, 0, 0. So you're going to simplify this one, guys. Here 6B1 minus 3B3 plus B2 minus 2B1. So I have 4B1 plus B2 minus 3B3. That you find there. Okay, look at this one. See, last row, R3. R3 row is gonna be 0 equal 4B1 plus B2 minus 3B3. This one can be 0. It depends on B value, right? So what are you gonna say if you say B1, B2, 3? It depends on B value. So you're gonna say this system equation have a solution, guys. Depends on B value, okay? So we're gonna say system is inconsistent. Understand? That depends on B value, guys, okay? So B value gonna be right there, guys. Let's say B1 is 1, B2 is 1, B3 is 1. That cannot be 0. So that cannot be 0. When you plug in here, right here, 4 plus 1 minus 3, that's going to be 2. 2 cannot be 0. So that case, system is inconsistent. So what are you going to say? This one is AX equal B does not have a solution. Okay? That's you're going to solve this problem. Let's do the practice question, guys. Whenever give coefficient metric and vector is right there, the question is AX plus B metric equation has a solution or not. If they have solution, which meaning is A column, columns of A, this one, This met column 1, A1 vector, column 2, A2 vector, column 3 gonna be span the R3. Okay, that's the same meaning, guys. Okay, so another thing is how we gonna know this has a solution or not. We're gonna using theorem. They said one of theorem statements saying theorem each row has a pivot, which meaning is right there, guys. Look at this one. Each row has a pivot. First row has a pivot right there, one. Second row has a pivot right here. Third row has a pivot right there. That case, you're gonna say you don't have to anything. AX equal B as a solution for every B vector. And another same thing is A1 vector span A1 vector, A2 vector, A3 vector gonna be R3. Another one say B1 is B vector gonna be linear combination of column of A matrix. All the three statements is the same.